Okay, guys, good evening once again, and welcome to the last section of our Cairo Bootcamp. I mean, this is the last, but we still have an additional section. I would just call it a bonus session whereby we would have Satoru team come teach how to contribute to Starknet, how to also contribute to Satoru, and also provide a few first issues of Satoru, right? So, and last week we explored Starknet's architecture. Yeah, Vic went through sequencer, data availability, and so on, right? But today we will have Wise Musa go through everything about Starknet everything about front end on Starknet. So I urge you to sit back and learn throughout this class.
All right. Good day, everyone. So this particular one is going to be an interactive one. And when I say an interactive one, I mean a truly interactive one, in the sense that I would need us to always give feedback of, like, I'll be asking a lot of questions. So while taking the class, to know the level at which we are, so that we can improve and learn a lot of things. So yeah, just like I said, my name is Musa Karim, also known as Wise Mr. Musa, and I'm going to be participating in this session today. So let me share my screen. Okay. Okay. So I believe everyone can see my screen now.
Yeah.
Okay. So we want to talk about front-end integration of Starknet. So, and basically, you all know how to write Starknet contract already. So you've learned about the zero knowledge proof, account abstraction, Cairo, everything about the Starknet. And now, how do you actually, and you've written and deployed your contract on the Starknet. So for most of your users, so it's not all of your users that are going to be developers. So which means your users still needs to be able to interact with your smart contract, just like they would interact with normal website. So for the integration, the major thing is that we are going to be looking at these things. So the number one thing is we are going to be looking at the Starknet JS API. Then we are going to be looking at what is a provider and what is a wallet. And then we are going to be looking at the Starknet React. Then we are going to be looking at how do we read data from Starknet contract and how do we write transaction to the Starknet contract. So starting with the Starknet JS API, right? So the Starknet JS API is a library that helps to connect your website or your decentralized application to the blockchain-based Starknet network using JavaScript or TypeScript language. So if you should look at this diagram that we have here, you'd see that in this place here, we have the Starknet network, and then we have your own DApp in this place. So in between these two, in between the Starknet network and your DApp, That's where we have the Starknet JS. Now, in the Starknet JS, these things that you see here, these are the classes or the utilities that the Starknet JS API expose you to. So I'm going to, let me bring this here so that you'll be able to. So basically we have we have the Starknet JS, and we have your DAP here, right? So we have your DAP, we have Starknet here. So the bridge between the two is Starknet JS. So we know that on Starknet, the contracts here, they are deployed as they were written in Cairo, and there are some things that you would see normally on Starknet. Like there are some things that are normally on Cairo that you will not find in JavaScript, and your DAP is majorly written in JavaScript. Most websites are written using JavaScript. So what's going to like give you, so, and when you say something is an API, so API means what? Application programming interface. So which means that it gives you an interface for you to interact. It gives you an interface for you to interact between the two. And in those interfaces, we have the signer, the utils provider. And you see that in this provider, we have two things. We have the account and the contract. So we need to understand what each of those classes, let me call them classes. We need to understand what each of them mean so that we'll be able to interact with the Starknet network. So we are going to be starting with the provider. So starting with the provider. So when we talk about the provider, basically it is just like if you are conversant with the Ethereum ecosystem also. So the provider is just what gives you the opportunity of reading from the blockchain. So we have the Starknet RPC provider. It gives you the opportunity of reading from the blockchain. So, and you can get it from Infura, Alchemy, Chainstack, or Nethermind. So when we talk about provider, it is just when you have the blockchain, you know that a blockchain, it consists of different nodes. So each of these nodes, if you want to read data from the node, you are going to require an RPC, a JSON RPC, for you to be able to read data from the node. So even though on Starknet, the concept of provider is like, okay, it is still restricted to just, so which means that if you want to read the provider, it gives you the opportunity of what? Of reading. So you need to take note of that. So the provider gives you the opportunity of reading from Starknet. And the provider is usually in form of a URL that you can connect to. So which means that now the Starknet ecosystem, when we talk about the Starknet, it can be in different networks. Either it is on the main net, or you are interacting with the Gwali version, or you are interacting with the local network or the DevNet. Any one of these is regarded as the network. So the provider or the JSON RPC is going to communicate with any of them equally, so far as you have that link. So how do you get a provider? How do you get a provider? If you want to get a provider, we have Infura. So if you want to get it from Infura, you just go to infura.com. So when you go to infura.io, you can create a new. So I'm just going to show you how that is done. So you can create, so I just created this one now. So you can say create new API key. So I am going to give it a name. So let's say Starknet Africa RPC, right? So if we have this, then we are going to create. So normally with the Infura, it's just going to, when you create an API key, it gives you access to a whole lot of blockchain technologies. So you can see Ethereum, linear, Python, like that. So you just come to the Starknet and you can change it to the Goerli version. And this is an API key. So let's just take note of this. So you can also go to alchemy.com also. If you go to alchemy.com, you need to sign in. And so for alchemy.com, when you sign in, you are going to create a new one. So there is usually limit to what you can do. So like I've exhausted all my API this thing here. So I can actually just delete this and just to show you how it is done. So if you want to just create a new app, you choose your chain, Starknet, is it mainnet or Goerli, then you give it a name. So let's call it Starknet Africa RPC, and we are going to create it. So this also is going to give us, this is the API key that we've got here. And for Nethermind, they have free this thing. Nethermind, Starknet RPC. Yeah. So you can see this is their own limited RPC.Nethermind. So with this, you can get access to the blockchain network, to the Starknet network. Now, how do you now instantiate? If you now come to so in the Starknet API, you can see this is the provider. Now, if you want, when we start the coding, you are going to see how do you instantiate your provider. Now, the next one is now the account, right? The account. So when we talk about account, it says that an account extends provider. An account does what? It extends a provider. So after this one, we have the account. So it extends provider. Account is provider plus signer. So we know that provider normally is going to give you the access to read. Now, when you now add signer to it, because Starknet, it has account abstraction, it means that there is no externally owned account. So normally on a network like Ethereum with an externally owned account, there is a uniform way of signing and verifying transactions. So, but this one now, since it is an account here, there's no externally owned account. All of them are contract accounts. So which means that they all have a way of signing and verifying their own transaction. So which means it is going to extend the provider with a signer. So this signer here, it gives access to what? To signing transactions. So since it gives access to signing transaction, it means that if you want to read, we use a provider. If you want to write, we make use of signer. Now there are some instances whereby there are some people that actually like just make use of the two. Like if they want to read, you can also use something that has a signer to also read. You can also use it to read. However, let's say if you are setting your provider and you are using now when you combine these two, an account, it usually lives inside a wallet. You usually have the combination of provider and signer inside the wallet. So which means that while we can make use of all these, Infura, Alchemy, Nethermind to just get a provider, all those ones are provider, when we combine provider and signer, we have an account. So now this account, they usually live inside wallet. And typical examples of wallets, we have the agent, we have Bravo, we also have the Snap by MetaMask. We also have the Snap by MetaMask. So these are examples of wallets. So these ones are like, standardized way of having combination of provider and account. However, you can also instantiate an account without providing a wallet. We are going to see the interface for that in the Starknet Js API also. So what we just need is, that for an account, it will require a private key. It will require a private key if you want to do it by yourself. But if you are using a wallet that implements the account abstraction, you just need what all of those details is already abstracted away from you. So that's what so when we talk about the Starknet wallet, so the Starknet wallet, it provides functionality to sign transactions, to declare and deploy contracts. Yes. So if you are using the Starknet wallet like Bravo, it gives you functionality of declaring and also signing transactions. Okay. So in this one, for example, let me say, is it 13? Developer. No, it's not this one. I think it's the agent one. Let me check the agent. Yeah, you can see declare smart contracts. You can declare a smart contract. You can also deploy a smart contract all from the wallet. So we have the agents. So we also have what we call the Starknet React. So Starknet React is just a boilerplate for starting a DApp project on Starknet. So we are still going to explore what it looks like. We are going to look at Starknet React. But under this one, what I'm just going to say here is that React, we all know what React is. So we know that React is a library, is a JS library for building front end, right? Now, and we know that for React, it has two major things. Number one is components, components. So which means that in React, you can build different components. Like you can build your front end in form of different components, and you can use the different components in one another. You can use one like 3 components to build another component and consume them the way you like. And we also have what we call reactivity. So reactivity is just about state management. So I don't want to go too much into explaining what reactivity is, but reactivity is just what React is solving. Reactivity is what the problem that React is solving. The reason for reactivity is because in if let's say if you say that in JavaScript, if you say let a equals to 3, and then you now use this a, you now have a function that is consuming this a, and it is giving you a particular value. If after you've initially instantiated this one to be 3, if you should change the value of this a somewhere else to be 5, this function here is not going to change, because the default is that it is not reactive. But when you have the reactivity, that reactivity is going to make this function that is no longer even in this place, after you have instantiated it, it's going to make it to change. And React is able to do this. React is able to do this using some what we call the React hooks. Now for the components, this one, it basically makes use of JXX basically to do this. So, and we have different React hooks. We have the use states, we have use effect, we have use context. So to me, these three are the most important. We also have some other ones like use reducer. We have use memo, use callback. So use state is basically used for tracking state change. So use state is also like a specialized version of this use reducer. Now, use reducer too is used for tracking state change. However, this use reducer, it's you are going to break the components into two. We have the state and also the dispatch. So which means that dispatch, it has the ability to like change the state in some dynamic way. So we have the use effect. It is used for if you want to perform a side effect. So side effect is when you want to make some change. When you want to make some change in the state, you make use of use effects. So I don't want to go too much into explaining what a side effect is, but normally when you have a function, we have functions can be categorized as either a pure function or a function that has side effects. So when you say that a function is a pure function, it means that the function, it doesn't make use of a state, like it doesn't use a state variable. So which means that, for example, some mathematical formula, if you, with the inputs, you will consistently be getting the same output. But when you say that something has side effects, it means that it's going to perform some extra things, maybe reading from state, writing to state, and all of those things. So that's what use effect is used for. And when you now talk about this use context, I'm going to explain what use context is used for. But use memo and use callback, these two are for performance. So you use memo when you have an expensive calculation that you don't want it to be repeating. So you can cache it in the memo, or memoization. So we also have the use callback also that is performing almost the same thing. So when we're now talking about use context, right? So use context is used for sharing states. When you use states, you can, you can just use it within a file. Let's say you are using it within a file. But when you use context, you are going to have it into two. We have the context API. It's going to have the consumer and the provider, right? So when you have to mount this provider on components. So when you mount the provider on, let's say, some components, and you have, let's say we have some other components here, it means that each of these components here that is mounted on the provider, each of them can consume the data that you are passing through use context. Now, the reason I'm trying to explain all of this because when we start coding, we just be making reference to what we've said they are going to be doing. So for the provider, now where are we going to be using this? We might need to send down some data. There are some data that we might need to define in just a particular place, and we would need to use them in every other places. For example, our provider and signer. These two now, we just need to, set them in one place. If we require provider, of course, we can just simply use the JSON, the RPC, and that's all. But for the signer, we would require the user to connect their wallet, which means that immediately they connect their wallet, we are going to get this signer, the account. We are going to get that account from them. So, and when we get that account from them, we just are going to be using it in different other pages. We don't want to continuously be asking them to connect wallets each time they are going from one page to another. So in that case, we would use context in that case. So, and whatever it is, then we can consume it inside any of the components that we have in this place. Inside any of the components. So that is basically Starknet. That's basically what React is all about. However, even React, they've said that you shouldn't be using React alone. So which means that if you want to use React now, the best thing is for you to make use of the Next.js, which means that we are going to be making use of the Next.js. Now, from Next 13 and 14, so Next has changed to a default of server components. Now, the reason we have, I'm not going into details of the reason why we have React, but now that we are using server components, it means that reactivity is turned off, which means that the default thing is the reactivity is turned off. So most of you would have seen this meme on Twitter, where you see use clients, that they now use clients, use binary. You would have seen all those memes. So a short explanation to the reason why you need to see use clients in the front of your code at times is just to turn on reactivity. So which means that it is when you turn on reactivity, that's when you can now start using all those reactivity hook. So you can now be using use state. So if you use state without this use clients in Next.js of 13 or 14, 13th or 14th version, then it's going to give you the warning. You are going to have hydration error. So you need to make use of use state in order for it to be able to use. So which means that normally we can also, it means that we can also have our application without this reactivity. So that's where React Server Components comes in. But for the most part of it, for the most part of this, we are not going to be using a lot of React Server Components. So we are still going to be using this use state. So when we get to where we need them, we are going to talk more about them. So yes, if you want to read data from Starknet's contracts, so to read data from Starknet's contract, number one is that we need a provider, right? We all know what a provider is already. Now, we also need the contract address. And we also need the contract API. I believe we all know what an address is, the contract address is. So when we now talk about API, API means application binary interface. So it's different from API. So API is when you have two, binary, two things that are binary. So you know that normally your contract is compiled into binary in the long run. So this one also, the JavaScript also, it is also a form of, it will also be in the form of another binary. So a way for the two binary to understand one another, that's why we have the API. So, and the API is mostly going to describe the function. It's going to describe the function, the mutability, the inputs, the outputs. So you are going to have that. So when you have these three, then the Starknet.
I don't know whether
Yes.
some free. Let me first reduce my.
What?
Yes. So I wanted to inquire. This for me. About the what? About the hackathon. First of all, okay, like this was my suggestion. I don't know, but is Outbox available on 9th?
Is that question directed to me?
Kayondo. Yes.
Okay. The details of the hackathon, it's the
Actually, he told me that we should discuss for him. He will like
Yeah. Hey man, I think after this class, we can just talk about that. So let's just focus on what's at hand. Okay. Yeah, that works, right?
All right, thank you. So in the Starknet JS, so we have the contract class, right? So we can import contracts, and it's going to require us to it has these three parameters. We are going to provide provider, contract address, and the contract API. Now, when we give it these three, when we provide it these three, then it's going to give us an instance of the contract that we've deployed. Now, this instance of the contract that we've deployed, we can now call, if we want to read, we know that the functions that we have, in our response contract, it can be a view function, an external function. So view, external, I think these are the major things. So view means that it is read-only. External meaning that it can change states. External meaning it can change state. So we can only use provider, like just ordinary provider, on view functions, which means that it's not going to change state. So if you want to read it, you are just going to say contract dot the name of the method that you want to call. So when you have that, the name of that method that you are going to call is going to give you back the result. Now, when it gives you the result, now the way you read it also, if it is a contract of version 0, you need to destructure it using .res. But if it is from version 1, you can just get it from that directly. So that's how to read data from Starknet. We are still going to code it. Then, how do you write data from Starknet on Starknet? So it is basically the same thing. How do you write data on Starknet? It is basically the same thing. However, so the contract is still going to be a contract from Starknet JS, and we are going to provide three things: the ABI, the address, and in this case now, we are going to provide the account. Though in Starknet, they will still call it provider again, but in this case, I prefer to call it an account, or something that has a signer. So in fact, if you just choose a provider and it doesn't that doesn't implement the accounts, or it doesn't implement, it's going to tell you that you cannot invoke with a provider that doesn't implement account. So the provider in this instance has to be account. Now, I mentioned that I mentioned the reason why I want us to separate between this provider and account. And the major reason is because, number one, if you want, there are sometimes that you might want in your DApp, you want some information to show, and you don't want the even without the user connecting their wallet already, So if your provider is from an RPC, if your provider is from an RPC, then you'll be able to display some data from your smart contract without even the user connecting their wallet, without your user connecting their wallet. But if your provider, if you are using your wallet as the provider, if you are using your wallet as the provider, then it means that when the user does not, when the user hasn't connected their wallet, all those read data that you are using to just make your application to look good is not going to show. So which means that we need to differentiate between a provider and a signer, or a provider and an account. So basically, the same way you call is the same way you also the same way you read is the same way you also write, except that the difference is in this provider and an account. The difference is in the provider and an account. So the provider that I use for this one, you can use a JSON RPC provider for this one, but the provider for invoking, it has to be an account. It has to be an account. So that is basically everything that we are going to be doing now, and as we are going to start coding. So if anyone has question, I think they should ask at this point before we go. Oh, this slide is chat now. Does anyone have any question? So I guess there is no question, right? Okay. So in the absence of question, then we are going to start working. So for the coding, I'm going to be making use of a template that I provided for, bootstrapping your DApp. So I'm going to be making use of the templates. Now, actually, I've the template, it basically has like everything that you need to. It simply makes the process of deploying, creating DApp on Starknet. It makes it seamlessly easy. So for this version of it, the front end is not integrated in it. Though I have another version. I have another version that the front end is integrated, but it is not released yet. So I'm going to be walking us through how to make use of the template to deploy our contracts, interact with it, and we are going to use it to explain all of those concepts that we've done. So in order to use this template, you just need to use the template to create a new repository. So if you want to check the template out, you can go to my repo/Kakashi, and you can give it a star if you find it useful. So you are going to create a new repo with it. So I'm going to call this Starknet.
Yeah. Sorry. Can you please share the repo in the chat?
All right. So yeah, if you want to code along also, yeah. Yeah, and you can give it a star if you find it useful. It's a beg. So you create a new repository. So just give it a name, Starknet Africa. Bootcamp. Let's just call it this. So it's generating the repository. So now that it has generated this repository, the next thing you want to do is to, to clone the repository, to have a local clone of it. So for me, code let me just make directory Africa. So in this place now, I'm going to git clone it. Now I have it in my local repo. Oh, that was a mistake. I was supposed to. Okay. So in this place now, I'm going to start decoding. So basically, if you want to start working on it, the way it has been done is such a way that the only thing you have to do is just to read this readme. If you can just give it a time to just read this readme file. So that's all you need to start working on it. So if you don't have some of the installations before, there are command lines to help you to just do them. So for this one, it supports local deployments. So if you want to install Katana, instead of going to their website to check the installation, just use this command. If you just put this command on your terminal, it's going to install it. If you don't have, we are using Starknet Foundry here. So if you don't have it, just use make install SM Foundry. Just copy the command and it's going to run. This one also, just copy the command. So this also, just copy the command. And so let's look at the code structure. So in the code structure, we have packages. So in the packages here, we have this lib.cairo. So this lib.cairo is basically the smart contract that we are going to be interacting with, right? So we can see that in this contract, it has this the traits. We have two functions there. We have the increase balance and the get balance. Now this increase balance here, it is an external function, or let me say it's state mutability. It changes states. So you can already see that we have a ref self here. So, but for get balance, this one, it is just a view function. This one is just a view function. So, and what we have there is we have the storage, we have the balance in our storage. And when you increase balance, it's going to take in an amount which is 252, right? So it's going to take in an amount which is 252, and it's going to increase the balance. So in this case, it wants to assert that the amount is not equal to 0. So, and it's going to write, you can see the self.balance is going to write the current, it's going to read the current balance and add the new amount that you put into it. It's going to add it to it. So if we should look at this, even though this is the boilerplate of Starknet Foundry, this is the boilerplate of Starknet Foundry, but it might make sense to make use of units, but let's use it this way. Let's use it this way. So if you want to, so just like I've said, if you now want to work with this, right? You're in the make file. In the make file. Oh, okay. In the upcoming versions of it, you have some other things that have been included to make life even more easy. So let's just check so that we don't so in the unreleased version of it, so there is an .env.example here. You can see. So in this .env.example, I can just copy this and let's just have here we have .env.local. Yeah. So in this place now, you can see in this place, the first thing here is Starknet RPC. The Starknet RPC, which RPC do you want to use? Which is the provider, right? So for this one, the provider that I'm using here is the local provider. So I can show you how to use the local provider before we even go to interact with the mainnet first. So for the local provider, we already have this. So the Starknet account that I want to use, I've already set up the wallet in this place. You will see that in this place, I have the Starknet Katana. Oh, okay. I've refactored some things. In the new version, but so I think what I did there was just to rename this one into wallet. So in the Starknet Foundry, yes, inside the Starknet Foundry, we have the wallet. Okay. So inside the Starknet Foundry, so I'm just going to rename this one to wallet. And I think we are good to go. So Katana account, Katana key, yeah. So we are good to go. Now let's look at how it is. If you want to, start, so just say make Katana. If you don't know what I'm talking about, just in the README section, you can just view the README. Or the make file itself to start Katana. You can see start Katana. So just make start Katana and it started the local deployment. So you can see when I was explaining it before, I said that, where is it? I said the Starknet network, it can either be the main net, Guali, your local network, or your DevNet. So what we are starting with now is the local network, which is we are running our own local Starknet network, which is the Katana here. So with this one now, that we started, we already know that. So in this place, we are just going to include our .env.local. So when we include .env.local, it means that the variables that we have here is going to bind it with everything that we have in this place, right? So now we want to, the smart contract, we want to declare this smart contract. You know, you have to first declare, then you are going to deploy. So if you should look at this place, we need to build it first, right? So we start, then we are going to say make build. So after we've built it, then it means that it has generated a Sierra code for us. If we go to the targets, so we now have the Sierra code. So let's look at where the Sierra code is. We need the path. Compare. So then we are going to say make declare to the targets. Okay, there is an error here. Key store file not found. Key store file not found. So, okay, I think the problem here was that where is the make file? Okay, it is because, so I'm going to just update the make file of this one. Yeah, I'm just going to update the make file. Okay, so everything should run smoothly now. Okay, so I think there is no .sierra in our target compared contract class. And maybe this was the Bro, we're supposed to have a um, yeah. So in this case now, the one we have to use is the contract class. We are using the contract class. So it's declared the Cairo one, it's compared it to Sierra, and we have the class hash. So the class hash that we have here, we are going to need it to deploy. So we just say make deploy. So then I think we put the class hash. So when we put the class hash, so you can see that as we are performing some things here, it is also showing them here. Like we can basically see So you can see all of those things in this place. So that in this case now, it has deployed the contract. So now this one is for local. This one is for local. Now, if you want to change it, if you want to deploy to Gwali, it is still the same thing. What we just need to do is to take an RPC. So let's use the Alchemy RPC. So what I'm going to do is, instead of that one, I'm going to, so I can have another .env for my, so I'm just going to have another .env. So I will have .env.gwali. So the .env.gwali is going to take in my Gwali this thing. So the RPC that I want to use, is this Alchemy RPC. So I'm going to put it here. Right? Now, the Starknet account that I want to use, so they so the Starknet account that I want to use and the key store. So the two of them, they are, the wallet that I want to use, they are the ones that I already have on my own. They are my wallets. So like, I'm just going to show you how where it is. So I have them stored here, Starknet wallets. So in this place now, so this is just what I'm going to. So I just have to change it in this place. Where is it? So I have account.json and keystore.json. Right? So it is just as easy as this is how I'm just going to set it up. So my Starknet account and my key store, the two of them, I already have them privately. I've already funded it. So I want to interact with the Gwali RPC now. So you can see this for interacting with Gwali, this for interacting with. So if I want to do it now, what I just need to do is to, in the make file, instead of using .local, I'll just use .gwali. And with this, I will, so still the same thing. Oh, I will have to go back to Starknet. Oh. Oh.
Yeah. Are you talking to me?
No, no, no.
Okay.
Okay. So from here, I'll just say make declare. So I'm declaring I'm declaring it again. So I'm going to use the password of my wallet. Okay, so I've declared it. So the contract declaration transaction, this is it. So, and you can verify that on the Goali. It's going to be on the Goali. So the class hash, this is the class hash that it has given. So we are going to make use of the class hash. So make to deploy. So using the class hash. So it's basically the same thing. Yeah. So it has deployed it. Contract deployed into this. So it has deployed it as this. So I can now go to, what's it called? Start scan of Voyager. To search for the transaction. Oh, it hasn't found this. Okay, maybe without contract deployment transaction. Let's try to see the transaction first. Okay. So this is the transaction that deployed it. Is it successful yet? This was the transaction event contract deployed. So it's deployed this contract from this. Deployed contract. So I think this, let's check. Yeah, that was the, so this is the contract that it's deployed. This is our contract that it's deployed. So which means that our contract is now on Gali. So we can see how easy it is to simply deploy our contract. So the next thing is going to be to interact with our contracts, right? So, and you can see now that the contract now, this is the contract API. And you can see what we have in the contract API. So let's just take note of that. We know the contract API, we know the contract address. We know the contract address, so we can already be doing a lot of things with it. Now, it now divides our contracts into read and what? Write. You can see the read. So this is the read. For read, we have get balance. You know, I've talked about that before. And we have the write. Now, let me show you something. You see that in this read, I can query the read without connecting anything. The read is currently at 0. The balance is currently at what? 0. Now, but the write, before I can write, it will ask me to what? To connect my wallet. So when I have connected my wallet now, so I'm going to write, let me write 20. If I should transact, then it asks me to what? To sign it using my wallet. Then I have signed. Now I have transacted. I can now go back to the read contract. If I should go back to the read contract and I query it, you can see it is now this 14 is hexadecimal. That's this one here is 16. 16 plus 4, that's 20. So in decimal, 20, right? So we can already see the way it works. It's just for us to write the code. We have read and we have write. Okay, so we already know our, now let us now go to the front end. So if we are going to be adding the front end to this now, we are going to be using the next. So just like I've said, let's go to nextjs.org. So do we have any question before we move on again? Do we have any question? So I guess there's no question. So if you want to get started, so we just need to, in the installation, we just have to put npx create next app, right? So, but instead of using what's it called? I'm going to be using Bun to install it. So instead of npx, I'm going to be using Bun X. So, and yes, I'm going to be doing, so let me, so in the packages, so I'm going to so what is the name of our project? So let's just make it Starknet. Starknet. Do you want to use TypeScript? Yes. Do you want to use ESLint? Yes. Do you want to use Tailwind? Yes. Do you want to use SRC? No. Approuter? Yes. No. So, and that's going to install it. Okay, so we have our next JS application already. So what I'm also going to do is I'm going to make a makefile to start our next JS app also. To start our front end also. So let me just post the name. So from here we have Bun dev. So start front end. Let me just use like this. Start front end. So from here, I'll just say make start front end. And it has started the front end on port 3000. So I'm going to open that here. Port 3000. So we have this. This is how Next. Yes, API. Now, so in the front end, I prefer to just have a blank, what's it called? So I'm just going to delete all this. Okay, hello from Starknet Africa. So, and in the global.css, I hate all these things. So let's look at what we have again. Okay, I think this is cool, right? Then we can now start working. So just like I've said previously that we are going to be working majorly with Starknet JS. So let's go back to Starknet JS. So the first thing that I want to do is that we want to be able to read from our contracts. We want to be able to read from our contracts. That's the first thing that we want to be able to do. So we know that for us to be able to read from our contract, we need this Starknet JS. So let us first add Starknet JS to our code. So let me see where we are here. So in the Starknet front end, we are going to do born add Starknet JS. Starknet. Is it Starknet JS? It's Starknet, yeah. So we've installed Starknet, which is basically Starknet JS in our application. So if we will need, number one, we need the provider. We need to be able to set up the provider. How do we set up the provider? So there are different ways to set up the provider. Just go to the classes, provider. So, and in the provider here, you are going to see the different ways in which you can set up a provider. Not started seeing them. Oh. Okay, I think these are what are inside provider.
Yeah. While you go through I think there's a question in the chat if you will attend to that later.
Okay. Okay. Yeah, the reason I use Bonex is because I'm using Bon as the package manager instead of Node. So I'm using Bon. So Bon is also a package manager, just like Node, or is a JavaScript runtime rather. So, and according to the planes and the benchmarks, or what we can even see, it is much more faster than. It is much more faster than Node. Okay, yeah. So to make use of the provider, we are going to import provider from Starknet, right? Then to connect to connect it to mainnet, to connect it to testnet, you can see. So if you just copy this, you are good to go. If you just copy this, you are good to go. Now, but we are going to be making use of, we are using the Alchemy provider. So we are going to be using this. No. So, I don't know why all these ones are giving stuff like this. So in the app, in this place for now, though it's not ideal. So let's just put this here. Add on missing, but you can see it's provided it. Now the API key, the Alchemy key or the API key, normally is just if you look at it, this one is mainnet. Let's go back to the Alchemy dashboard. So you can see the way it is Starknet gradually. So I can just copy this and paste it here. So, but you know, because of security reason, right? So you're not meant to put your you're not meant to put your API key. You're not meant to put your API key directly in your application. So it's actually also easy to do. So what you will do is in this you are going to have .env for this also. I mean, yeah. So for in this place also we have .env.local. A good thing about Next.js is that it's going to automatically bind it for you. You don't need to do anything. So I can just copy everything here, right? And I'm going to paste it here. Now there is a syntax for public, I think. So you have to do next public RPC. So I will need to check to confirm that how to use .env for public environment file. Yeah. Yeah, so you have to use next public. If you want, so the thing is .env files, if you are going to be using it inside the application like this, you need to make use of that next public. You need to have it in front. So in this place, you are just going to say process.env. Yeah, so we have this. So this is the provider RPC. So we've already got provider RPC. Okay. So the next thing is for us to get the contract, right? So we are going to, so we know that we say const our contracts equal to new contract. Now, for contracts, it needs three things: the ABI, the string, and the provider or account. The provider or what? Account. So ABI, address, provider or account. So for the provider, we are using provider RPC. So for the ABI, we will go back to this place and copy the ABI. So this is the contract ABI. So in our next JS, in this place, we are going to create the utils folder. Inside the utils, we are going to create the ABIs folder because we might have more than one. And inside this, we will say our contract ABI. The JSON. So we have that. Then from here, we can now import our contract ABI from at fifth. Slash ABI slash this, right? So we've imported the ABI, then we are going to put it here. So we have our contract ABI. Then the next thing is the contract address, right? So let's just add code it here. Our contract address equal to so this is the contract address. So put it here. Right? Then we put our contract address here. Okay, so we have our contract. So in our contract now, which function do we want to call? We want to call this read function, which is get balance. We want to call get balance. So we just say our let's balance equal to our contract dot get balance, right? Okay, so if this then in this place, wait. Now I'm thinking that it's looking like oh. Okay. So the way it is now is that we can only so we have to await it, and we cannot do this in this place. So what we are going to do is there is need for reactivity. There is need for reactivity. So I think we can use effects here. But before that, we have const balance and set balance. So this will be equal to use state. So now, do you remember what I told you about use states? Ah, it's like I'm the only person here. And I'll say this was going to be
Yes, we
interactive.
remember.
Yeah, with you.
Is it on the side of, are you supposed to use it with use client?
Thank you very much. So we cannot just use states. We have to use clients in order for us to do that.
Yeah.
Okay. So we need to use clients. So at the top of this, we need use clients. You can see. Do you have a question? Ooh. Okay. So we have use clients. Now we are going to be making use of we now use effects. So I've told us about use effects before. So in this place, we have use effects. And the way use effect is used is that we have so we want to call an async function.
Can you hear me?
Yes, yes.
Yeah, I sent you the red message.
Yeah,
sorry for this.
I've seen the message.
Okay, cool.
I think
Cool. No
it's
issues then.
more. So we now bring this one that has our weights inside there. Let me just do that. Then we are going to set balance to the balance. So in this use effect, we are going to call get balance. Okay. 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 So it's using everything. Yeah. So with this now, we can just put this here as balance. So let's see what we have in our what's that? But yeah. Oh, 17. Oh, what's expected token? Oh, this means. Oh, okay. Cool. Looks like the RPC is doing somehow. Okay, it looks like the RPC is doing somehow. So we are just going to like come back to it. Now, to get an account, there's another RPC that there's another dependency that we are going to be making use of, which is basically get Starknet. Let me look for that one. So we are going to install that one. So burn add get Starknet. So in the get Starknet, it's going to give us the some functionalities like we can connect some functionality to connect or disconnect. So this now, let's say I have a button and I say you should connect wallets, right? So, and I can say that on click, you should connect. Yeah. So in this case now, if I should click on this, oh, this one is still shining. Yes. Oh, okay, let's try this. Yeah, this was what it's supposed to bring out too. So you can see basically it's asked for me to connect wallets, either of the two. So I can, but on this Chrome extension now, I don't have either Bravo or Agent X. So if I should connect, it's going to give me the interface for either of the two. Uh, So in this place, I'm just going to have connect the functionality to connect wallet. So it will try to connect first. So the version. So use documents to return. No. If there is no Starknet object, it should be fine. Then you ask it to set accounts. With Starknet. So up there we are going to have accounts, step accounts, just to use dates. So Starknet window objects. This one we are going to make it Starknet window objects. Once this will be okay. Then we need address also. Set address. Set address. Starknet dot selected address. Set is connected. So this one is going to be string or undefined. Then we also need to check const is connected. Set is connected. Okay. So with all of this now, we will set is connected to be true. And the zero should alert with error dot message. Okay, so this connect wallet here is going to on click it will connect wallet. It connects wallets on click. So, but then what wants to happen here is connected. If it is connected, it should show if it is connected, it should show disconnect. So let's check this. Okay, so it is connected like this. So the reason some of these things are not showing is because the wallet is already connected. So I will need to make something to also disconnect wallets. So disconnect. Okay. Set address. Everything should be undefined. Set is connected. Pause. So connect wallet, connect. This one should be disconnect wallet. Yeah. So if I should now the wallet is connected. The reason it's not showing it is because it is cached. So this one it is disconnected. So that's the meaning of what we have here. Then we already have accounts in this place now. Let's try this again using accounts here. Accounts. Accounts. Okay. Yes. So this is it. So this is the balance we are reading from the contracts. Let me. So this is basically the account, the balance we are reading from the contracts. So that's 20. So which means that if, let's say, we increase the, let's increase it again first by 40. We should increase it by 40. Oh, okay. If we should increase it by 40, so this one is going to show. Let me all right. So this one is going to show. So basically, to write it's still the same thing. Since we are using accounts now, since we've set up accounts now, so it means that to write is also going to be the same thing. It's just going to be, where is it? So it's just going to be providing the accounts, setting up the contracts, calling that particular function, and providing whatever arguments that we need to, and that's it. So that's basically how to read and write. So that's basically how to read and write contracts from on Starknet. So do we have any question? I think this is where we are going to stop. Do we have any question? So I guess there is no question. Okay, so the balance is now.
Maybe the question is, would you have like a GitHub repo?
Yes.
Okay.
We are going to have access to it. It will be uploaded and we all have access to it.
I also didn't get to understand what was the main difference between is it banks or from NPX? Is it that it is faster or
What? Sorry, I didn't get that.
when instead of using NPX install, you used some other command? Is it that
Yes.
is?
Yes, it's set to be faster. That's the reason.
Okay.
So is there any other question? Okay, so in the absence of no other question, I guess we are going to call it a day here. So I'm going to update the repo, and I'm going to push it there so that everyone can check it out. Thank you very much.
Thank you too.
Yeah, thanks, man. Thanks for the section. And I believe that everyone that paid attention like got something, because you took your time to explain some of this concepts. And yeah, so everyone that has actually participated in our bootcamp, we will have a spoke for you guys. We'll have something like proof of attendance. So later this week or probably next week, I would request for your Starknet address so we can send them over to your address. Can we slip your address and send them over? But apart from that, we are hoping to see you guys in the bonus section that we'll have with Satoru team, where they will put us through on how to contribute to their project, how to contribute to Starknet in general, and also how to get involved with their project generally. And yeah, we believe that this bootcamp has been impactful to most people.